Good afternoon. We will now continue with Chiara Marletto and her book Science of Can and Can't. Sorry about the fussiness. I think I had too much champagne celebrating the 1400.
Too many cookies.
Too many cookies. I do actually have too high blood sugar level. That could actually make you clumsy. I left off at 112 and we were talking about the cups that Chiara stumbled upon close to her parents' summer abode. It was an old lady that tricked her to do free work for her in exchange of the possibility of winning one marble. I don't know. I'm happy that Chiara never turned into economy. This is the second paragraph on page 112. You can imagine a standard procedure to set up the game. First, toss a coin. If the coin shows heads, put the marble under the cup on the left. If it shows tails, put it under the one on the right. At this point, for the player, the bit is perfectly randomized and maximally unpredictable, because it could hold the value 0 or 1, each with the probability 1/2. For the person who sets up the game, however, the bit has a definite value, either 0 or 1. They know where the marble is. Now imagine setting up the game with systems that behave according to quantum theory. Not simple information media, but quantum information media. What would change in the game? Our quantum game involves a photon, a quantum particle of light, instead of the marble, and 2 possible paths instead of the cups. A source emits the photon. Then the photon can travel straight along a horizontal path or along a vertical path. The photon and its path constitute an information medium. They can encode a bit. If the photon travels on the horizontal path, it encodes a 0. If it goes on the vertical path, it encodes a 1. It is possible to set up the game by following the randomization procedure I explained earlier. But this would not lead us to a quantum game. For example, someone sets the photon to travel vertically or horizontally according to the output of a coin toss. Again, the chances are a half for the player to guess correctly which path the photon is on. As you can see, this version of the game is not different from the marble game because it does not use the quantum properties of the photon in any way. We need to explore some other kind of setup using the quantum properties of the photon. What is the quantum stuff that the photon can do while a marble cannot? It can be prepared in states that are exclusively quantum. In the sense that they do not exist according to classical physics, but only under quantum physics. An example of these chiefly quantum states, which is relevant for the photon, in this example is what I shall call a superposition of the horizontal and vertical path. In order to understand what kind of state this is, how it is related to the states where the photon is on a definite path, and what counterfactuals have to do with all this. We need to look at a definite experiment where the photon is prepared in a superposition of different paths. And then certain measurements are performed on the photon. This will tell us how the superposition is, in a certain sense, similar to the state of the marble, but is fundamentally very different. The photon, after having been emitted by a source, can be put into a superposition of paths by guiding it through a special kind of crystal. Which, when interacting with the photon, causes it to split along two paths, horizontal and vertical, as in the figure. If you were to guide a beam of light made of lots of photons through this crystal, you would see that the beam is split across the two paths, horizontal and vertical. Which is why sometimes this crystal is called a beam splitter. But here I am talking about a single photon, not a beam of light. And what it means for it to be split can be understood only with quantum theory. So what do we mean by the photon being split across two different paths in a quantum superposition? Well, one key aspect of the superposition is that after passing through the crystal, the photon could be found with probability half on the horizontal path and with probability half on the vertical path. When the photon is in a superposition of different paths, it is impossible to predict with certainty which path it is on. Its path location is unpredictable. Experiments happening daily around the globe in the quantum laboratories confirm this behavior to the highest precision. Does this mean then that when the photon is in a path superposition, its properties are exhausted by saying with what probability the photon is on one path? And with what probability it is on the other? Just like for the marble in our classical example with two cups. No. In reality, the story is much more subtle. Quantum superpositions are not all about probabilities. The photon is not a randomized bit. Even if, in some instances, it can look like one. The first difference from a randomized bit, such as the marble, is that no one can predict with certainty which path the photon is on. Even when the person who prepared the photon superposition cannot predict that. So the old lady has drawn a very low card. She won't even know herself. The unpredictability of the photon path is absolute, unlike the case of randomization. The person who prepared the photon knows all the details about the situation, yet cannot predict where the photon is. The photon is in a quantum superposition of two different paths. When in that state, it does not have a definite position. And if you were to measure its position, that measurement would have an unpredictable outcome. And maybe the last bit here is the most important. Even if you were the old lady and you were handling photon, all the measurement the old lady would have made to the photon, trying to localize it, trying to know its position, it would not amount to anything at all. The photon is foundationally unpredictable. In contrast to the marble game, where the old lady has absolute control, there's no chance where she puts the marble. Whereas in the case with the photon, there is no control whatsoever. I have to make a joke here. In a nutshell, the same nutshell as the marbles are put into. In a nutshell, this is the kernel, to make another joke, of quantum mechanics. The realization that the outcome is absolutely unknown. And put on top of that, it cannot be known. Not for anyone. It is inherently unknowable. Nothing in our everyday world is assumed to be inherently unknowable. But the photon is. And oddly enough, dear folks, that holds for the rest of the world. But that is a question for another time. Now it might be a question here from my dear associate, Kalle Lundahl. The one and only.
Hello again. It was interesting. By chance, I didn't know what you would talk about, except that you would discuss Chiaramarletto today. And I took this Cree volume in the Loeb series, Greek, English on the other side, and it has the dialogue Cratylus by Plato. And before you came in, I wrote down that phrase. Let us take a look. So you have that phrase from Plato. So it's from Cratylus, dialogue Cratylus by Plato, 421b if you want to find the exact passage. And the phrase there, so the Socrates derives the word aletheia, truth, from these two words. Theia is the same, is the adjective that you have also in the noun theology, divine, and then hali is a noun from, that means in English wandering. It often has a negative sense, like in mind wandering in common day use, but I suppose it can also have, as far as I can see, also a neutral meaning, wander around. And here we spoke about photons, that you can, even if you would measure it, do your very best to measure it. So unlike a marble game, you cannot measure the photon. So it's like a photon has its own divine wandering. Theia hale. This is an accent like hale, like an H, hotel in English. Theia hale is a divine wandering, I think. So it's what do you think about if you would juxtapose? We have aletheia always spoken about this other known etymology of aletheia that Heidegger uses, lethe, forgetfulness, that Heidegger uses, but here we have another that Plato uses, perhaps playfully. We know Plato was inspired by Heraclitus, so this could be a reference, perhaps a vague one, to Heraclitus, divine Pantarei, and so. What do you think, Theia, about this new etymology, so to say, to aletheia?
Yeah, definitely. Divine wandering. This is what it is about. It's definitely divine because we humans cannot tell the path of the wandering. And all of a sudden it becomes miraculous. And that is actually the very phrase Niels Bohr is using. Miracle. Not in an exaggerated way, in a technical manner. It is a miracle. The world is miraculous. This is the important lesson taken from quantum mechanics. I do like
Theia hale.
Theia hale.
Modern Greek.
Properly pronounce it. I say thank you very much and have a wondrous afternoon. Bye bye for now.
Thank you.